we would like to welcome our next set of speakers, Lavanya Kalaiselvan and Arnab Majumdar. Lavanya has over a decade experience in software industry. She assure quality applications and always delighted about sharing the acquired knowledge. Arnab has nearly 11 years of experience of software quality assurance in IT services, primarily working as a non-functional test analyst. And they would be speaking on the topic redefining DevOps for seamless performance testing. Over to you, Arnab and Lavanya.
Thanks, GTR, for giving us this opportunity to present here. This is Arnab Majumdar, and with me I have Lavanya Kalaiselvan, and we both work in Cognizant Technology Solutions and have more than 10 years of testing experience, primarily in non-functional testing domain. Today we'll have a brief discussion on challenges of DevOps in performance testing and how we have implemented a DevOps model for a banking payments application using customized solutions. Also, we'll discuss about the most unique feature being a deep learning based performance tuning solution, which helped to integrate every aspect of performance testing in this automation model. As we all know, DevOps is gaining rapid momentum in software delivery process in recent years, and its market is expected to grow almost 4 times between 2018 and 2023. Still, most of the organizations face challenges to implement DevOps in software testing lifecycle. And one of the key factors is to achieve continuous performance testing in the DevOps process. It consists numerous effort and time-consuming activities with significant human intervention, making the overall testing lifecycle costly and lengthy at the same time. So we chose this payments application to implement our DevOps model because of its significance in the overall banking business. It is a very complex architecture having huge number of rule engines, different applications and database tiers, and multiple interfaces to process a single payment. During peak load hours, this handles around 25K payment transactions and settlements. We have monthly releases for this application and 20 plus changes are introduced each release. Due to all these complexities, we have implemented DevOps for this particular application. The implemented DevOps model is a combination of industry standard tools like Jira, Jenkins, Selenium, Performance Center, and in-house developed softwares such as Result Analyzer and Defect Triage model. Jenkins plays the central role to trigger all the automated activities in sequence throughout the lifecycle. Once an NFT requirement is logged into Jira, it provides those requirements to the functional Selenium automation scripts, which are then used to create performance test script compatible with LoadRunner tool. Next build is triggered to enhance the load test scripts to make them ready for test execution. Once the scripts are ready for execution, next set of activities are triggered by Jenkins to create and execute the load test scenario in the Performance Center tool. Once the execution is completed, Test Result Analyzer tool is triggered to collect all the performance metrics for Performance Center and server metrics from AppDynamics through Elasticsearch and provide a holistic performance test report. In case of test failures, Defect Triage model is triggered, which uses deep learning algorithms to pinpoint performance hotspot and provide necessary recommendations for performance tuning. It raises defect in Jira to appropriate teams to work on those recommendations. In the next slides, Lavanya will explain the custom solutions in detail.
Thanks, Arnab. As the overview of the solution is explained, we have forthcoming slides to explain about the detailed aspects of the implemented solution. As a performance tester, the 3 areas we will really spend a lot of time on repeated tasks being scripting, environmental setup, and result analysis. So we have made in these areas. Considering scripting, we have used the Selenium automation scripts to capture the network traffic, and the same has been converted to performance test scripts. The main challenge being the script enhancement part, which includes parameterization and the necessary correlations. Even we have automated the same with customized Java codes. Environmental setup will differ from application to application. For our testing, we have used Unix jobs to automate the environment health checks and ZibaOS like. Once the prereq check was established, the scripts can easily be uploaded and the scenario can be triggered using the PC REST APIs. Next critical step would be result analysis. We have developed an in-house analyzer tool serving as a one-stop solution using Java Spring Boot framework with a lucrative UI, which provides an in-depth report on the performance metrics, SLA breaches, if any, If the test is passed, we can just wrap things up here and the analyzer will automatically send the report in PDF format. But in case of a performance issue, the result analyzer tags the test as failed and triggers the next part of the solution, which is deep learning based performance analyzer bot. As Arnab has mentioned about the complexity of the payments application, just one high value payment needs to go through 14 app tiers to process its. In addition, there were a lot of components and interfaces to analyze and assess. In case of even why it will only be possible for an application expert to split the time spent on one particular payment journey against the traversed application. Now, imagine if we need to do the same for a load of 25K payments per hour. To ease the process, we have optimized it through deep learning algorithm to isolate the performance issue and to identify the exact root cause. I'll kind of split this into 3 steps to make it easy to understand considering the time. Step 1 being the performance hotspot analysis, wherein all the logs will be extracted from the involved application and will be fed into the classifier, where every line item of the payment journey will be categorized along with the time spent in each phase. So now it is easier to identify the application under concern just by comparing the stats against the baseline. We have achieved this with deep learning with TensorFlow backend. We had 7 years worth of data and we have used them to train the algorithm with which we could optimize it to an accuracy percentage of 84. Just to add few technical aspects, we have used dense layer type and rectified linear activation to build the layers. Once we isolated the application under concern, we can just concentrate on the particular application for root cause analysis instead of getting experts from all the areas, which will definitely save both time and money. Now on to step 2, root cause analysis. Usually for root cause analysis and tuning recommendation, we do need performance experts or technical people from relevant area for right advice. But here we are trying to automate that path with regression algorithm to identify the responsible hyperparameter. Root cause of a performance issue, say a sudden spike or gradual increase in response time, maybe due to different hyperparameters such as actual response time issue with the code or data used, or with respect to the server utilization metrics that can be caused due to system processes instead of the actual application process. To identify the same, here we are using feed-forward neural network algorithm and train the model with response time, throughput, utilization metrics as inputs and expected output. Once we pass the performance metrics from application under concern against the model, we'll get to identify the responsible hyperparameter. Again, coming to the technical details, we are using Keras with TensorFlow backend to implement the model and we have used sigmoid activation function. Once we find the exact issue, we can just pass the piece of log through step 3, which is defect triage algorithm, wherein we are using the same classification algorithm as step 1 to identify the recommended steps, we are getting the recommended steps as output to follow.
Lavanya, 7 minutes up, okay?
If at all this has happened in the past. If not, we can just pass the details to Java code to raise a defect against the proper team in Jira QC. Both the ways we are benefited. This is the final step of our pipeline, enabling the performance testing and tuning onto DevOps, and we have redefined it with the power of deep learning. So definitely this is just not a common DevOps model to stop, wherein we'll stop after test execution. We have gone all the way through performance tuning, and even we have enabled the feedback loop so that it can exactly fit into the DevOps model. From benefits point of view, as per our implementation, we have reduced around 40% of testing effort, 55% of analysis effort, and we have also reduced the dependency on skilled resources. In addition, we have used all the in-house tools, incurring no additional cost to the establishment. The main advantage of the solution being we can tweak the model easily to any other, if we want to do or implement the model for implementing the DevOps pipeline. Thanks for that. Thanks for providing us the opportunity in speaking for ADHDR. Thanks for that.
Thank you so much.
Time.